Hi, Volker. Welcome.
Hey, good morning. Hi, nice to see you or hear
Yeah,
you.
both. What was your first computer?
Oh, it's hard to say. I think my first personal computer was a Schneider CPC. That was very common in Germany.
Hmm.
I think in Great Britain it was called Amstrad CPC. It has a Zilog Z80 CPU.
So
And
Schneider was Amstrad.
yeah, Schneider was Amstrad. It was the same thing. Yes.
This learn something new. This is what I didn't knew. Yeah, because I had indirectly an Amstrad because I had a Spectrum. A Spectrum was bought by Amstrad. So at the end, I had an
Yeah,
Amstrad Spectrum, but it was
exactly.
actually a Spectrum. Hmm.
Yeah, they had the same CPU, the Zilog Z80, 8-bit CPU.
Oh,
The,
okay.
the
And why
cool,
you got it?
why I got it?
Yeah, why?
I don't know. I don't remember if I had it before we did some informatics in school or not. But I like a lot of my friends had Commodore 64,
Hmm.
and but I was never really good in gaming. So I gave up gaming quite early already, and like the Schneider CPC was better for programming. And
Hmm.
the cool thing, it also had like CPM, which was a real operating system, not just basic. So you could basically boot CPM from floppy, and then you could run Turbo Pascal on CPM. So
And
uh,
the CPM was available only for Schneider, or could run on different machines?
no, CPM was really was an operating system which ran on various other
Hmm. So it
operating
could run on
systems.
Spectrum as well.
I'm not sure. I never had a Spectrum. As I said, I started with a CPM.
But this was new to me because for me the world started with the console, which was basic. So what I had to do is to load and yeah. But I never knew the CPM that Schneider or Amstrad had a operating system.
Yeah, so as I said, like with CPM, you can boot it, and then you had a real file system, and you could do cool things like
Wow. And
yeah,
and
load
who created the
files. And
CPM? You know that this is like the Amstrad company, or who was behind CPM?
no CPM.
I can research later as well. But if
Yeah,
you know,
it was definitely not Amstrad. They licensed it just so it.
okay.
I don't know. Maybe it was a
And was it
predecessor of
like
MS-DOS, like
commercial or not commercial? Was it meant to be used by enterprises companies, or was it more like leisure OS?
no, it was a professional operating system.
Hmm.
So and yeah, I mean you had to license this if you want to use it, but it was a add-on to the Schneider CPC. So
Huh.
I didn't have to buy it. It was there, but
So after
yeah.
300 episodes, I learned that. So this is interesting because the CPM I heard about that, but I thought this is like an extension of the Schneider or whatever. But CPM that this is OS. So I will have interesting actually, really interesting. Um,
Yeah.
okay, and so you said you never were good at gaming, but you enjoyed gaming or not?
I mean, it somehow get me my first encounter with computers, because some of my friends or my relatives they had this Commodore, so
Hmm.
they showed me how the games, and I obviously played with them, but as I said, I was never good at it. So yeah, when I got the Schneider, I started doing like basic and then Turbo Pascal, and
Cool.
I had this cool word star, so
Ah,
I did some things for school. I bought a Star NLC a needle printer with 9 pins, 9 pins, so I
nice
could do
sound.
that. Yeah, it made nice sound, and it it got I could do my first school homeworks with it, and
But what motivated you? What do you wanted to achieve with the programming? So what do you wanted to program?
I don't know. It was just interesting for me. I don't know it. In school we had this pocket computers like Sharp. I don't
Uh-huh.
know. It was called Sharp. I don't know the exact model.
Hmm.
And you could also program it in the kind of basic. It only had like 2 lines of LCD display,
Hmm.
but
In
we had
BASIC.
yeah, it had a basic, yes, and we had a good teacher. I think many things start with you have a good teacher, and
Yeah.
he made me really interested in this. And we started doing like small programs like sorting stuff or like these guessing games or stuff like that.
On the
Implementing.
calculator.
Yeah. It had like, I don't know, 60 kilobyte RAM or something like this.
And how you could load the stuff? You had to write on the calculator, or could you write it externally and load it to calculator? You know it?
I think there was an extension to save it somewhere, but I think we didn't have that at school. So you could basically save it in the calculator, and you had to.
You could save it, right? But you could save it in the calculator. Okay, that's good.
So I just checked it here in my cell phone. So CPM was really developed by Digital Research. So the ones who did DR DOS later on, maybe you remember that.
Yeah.
So I bought that for my first PC later, because it was kind of cooler than Microsoft DOS. There was this Digital Research DOS, which could use like HiMEM.
I remember HiMEM.
Yeah.
There was a batch. There was a batch command for the HiMEM, right? So you could.
Yeah, exactly. There was a special driver to load this HiMEM stuff.
But this HiMEM was also available on MS-DOS, I think. No.
Yeah, it was, but like in MS-DOS, it was like more complicated. You had to do this batch stuff.
Yeah, exactly.
I think with Digital Research, it automatically used it. And
cool.
The other cool thing I just remember now with CPM was also that it had this overlays, so you could also use more memory, like not just the 64 basic memory, like CPC at 128. So
wow,
you could use more of that. And it also had like Logo. CPM had not just Turbo Pascal; it also had a Logo programming language.
Yeah, Logo was cool. This was with the turtle.
Yeah,
you could turn left, right, go right. You could draw stuff.
Exactly. You could draw nice pictures.
Vector graphics. This was the start of the vector graphics, right?
Vector graphics, but also fractals. Like you could draw these nice trees or farm leaves. That really impressed me at that time. That you can like with a few line algorithms draw this natural like plant resembling pictures.
Yeah, but it was math basically, right?
It was math, yes. So as I say, it impressed me that like a farm leaf, which looks so nice, is basically can be defined by a few lines of math.
This scared me. I remember logos. Okay, this is such a strange formula, which is crazy complex. You have to understand that to generate the images. So for me, I look at that as like, no way I will understand this ever, right? Now it's easy, but if you just have this is really hard to comprehend. And what I remember, I think it was Logo. Someone created a clock, with the hands and then moved around, and this was already somehow sophisticated math, because at least you need I think sinus or cosinus to calculate that. So I was also impressed by that, by the knowledge of other developers. Okay, they are really smart.
Yeah, I remember we had in our school library, we had this book about Lindenmayer systems.
What is this?
And Lindenmayer systems is basically you start with a pattern, which is like a few letters, and then you have these rules to replace. Like you replace A with ABC and B with AB and so on, and you start with a word and recursively apply these patterns. And with this, you can create quite sophisticated or simulate like plants or other patterns. And I mean, this was like in the 80s, right? So
Lindenmayer systems, you said?
Yeah.
Okay. I never heard about that. So I learned a lot now in the podcast. No, the first 10 minutes and everything is new. So I will never invite you back, because you will cause 4 hours research after 10 minutes. Okay, Lindenmayer systems, and it was like biology, or was it computer science, or who was it?
Yeah, it was basically a combination of biology and computer science, and this really interested me at that time. Like when I was
how old were you?
like, I don't know, 15, 16 years, like,
Crazy.
yeah.
Okay.
And I was more interested actually in biology at that time. I wanted to study something with biology, but then like at that time I also got my first computer, and then at school we had the first PCs. There's the one still without hard disk, with 2 floppy disks. So
Yeah, exactly.
3 2 5 and a quarter inch floppy
A
disk.
and
So
B.
on one you started Turbo Pascal, and on the second one you can had your own programs or stuff
Yeah, I
like
had one with one floppy, but it was three, the small one, 3.5, right?
yeah.
And but I have to
Okay.
swap the discs.
Yeah.
Yeah, but A and B, right, were the letters for the drives.
Yeah, A and B exactly, and C was the hard drive.
Yeah, exactly. It still is, I think, on Windows. No.
It still is, yes.
Yeah. um, um, cool. So, and okay, then why you were so interested in biology back then? So why? What you wanted to study? Why, or what you wanted to achieve?
I don't know. Like I had a aquarium at home. With I grew up some fishes, and I was interested in plants and exotic plants. I had like
Ah,
orchards and this how you call it, catcher plants.
mhm.
In German,
Ah,
it's
yeah.
like fleischfressende Pflanzen.
Yeah,
It's
this is
German.
what was also. This was of plants who caught flies.
Yeah,
I
exactly.
was fascinated by them. This was the same here. I wanted to have one, and I bought one and overfeed the plant, and it died.
Yeah,
So this is the yeah. But I was really highly fascinated. There are two kinds of such plants, right? They have a muscle. One is one moves, and the other one is boring. It just the flies they are not caught. There's like a glue, and they just
yeah, the
die.
glue.
This is the boring one. I was not interested. I was more interested in the moving one.
Yeah, there's actually more than that. There's the ones which have just like a cup, and they fall
Yeah,
inside.
exactly.
Yeah, so
There's digest system, so this was
yeah,
boring for
exactly.
me. So okay,
I'm
I,
actually still in the German catcher plants club since a long
association. You
association. Yeah,
no
since
kidding.
more than probably 40 years or so. Yeah, I'm like, I think I have member number 150 or so. So
Wow, this will be the title of the podcast. The fly catching plant association.
exactly.
Uh-huh.
In German, it's called like this. It's Gesellschaft für fleischfressende Pflanzen. So basically, goes on
That's
like that.
crazy.
Yeah,
So you are not serverless, you are flyless, right? So this is the
exactly.
flyless.
Yeah.
Okay, this also fascinated me. So this I found this really interesting that the plants are moving, and maybe I don't know. There were maybe a Jules Verne book or something about this as well. So some books were mentioned because I also sparked my interest in the. But I yeah. Uh, okay, so Lindenmayer systems with substitution, they
Yeah,
were able to simulate biology, right? So this was like
yeah, exactly.
okay,
And
this is
this book
interesting.
had like great 3D graphics, which was like, I mean, at that time it was impossible to do that with CPC or with the first PCs. You
Ah,
needed these workstations. But then when I started to study in the Tübingen University after school, they had this cool Iris workstations.
wow, Iris.
So SGI, I think Iris was the operating system. They
Mhm.
were SGIs, yes.
This
And
was the octane and oxygen. They had cool names. They look like
yeah,
a alien,
exactly.
right? They were
Yeah, exactly.
not blue but bluish,
Yeah,
and
yeah.
yeah.
And
Okay,
they
but
had
what?
real graphic cards, so you could really do 3D graphics on them. And Unix, like IRIX, which was a kind of Unix operating
Yeah,
system. So that was
but
really cool.
what happened between your in basic you said you what you created actually, what you implemented, between your school and university, some cool stuff. So what you try to build? So just interested, some apps or
Uh,
some attempts maybe. Do you wanted to
yeah, I
program a
think
game or
like I think my first program in in Turbo Pascal
Mhm.
was a game like this. I think it's called Reversi. In Germany, it's like something like Vier gewinnt, like where you have to
Okay. Tic-tac-toe
like,
maybe.
yeah, like tic tac toe is like just 3 to 3, right? So
Hmm.
there is, if you know how to play it, nobody can win. But this
Exactly.
other like is bigger. Like you have I think like 7 lanes, and they are 8 lines tall, and you
Mhm.
basically throw in from above.
This is like from plastic. This is a real game. You can
Yeah,
exactly. I don't know what how it's called, but I know how it looks like.
yeah, and I think I started doing this on my Schneider, and then later at the we had Turbo Pascal on the PC at school, so I worked a lot on that, but it wasn't easy because like I was at school still. I didn't knew anything about programming or theory or so. So it was like very naive approach.
Mhm.
And then I think the second thing I did was something more visual. So I was also impressed by these artificial landscapes.
Mhm.
So I started to do like this landscapes, which was actually also quite simple algorithm. You started with a mesh, like a 4 2
Ah.
mesh, and then you always put points in the middle of this mesh and made the mesh finer. And then every point in the mesh had an altitude, and you created the points in between, which made the mesh finer by changing the altitude by a random number.
Mhm.
And then in the end, you ended up with something like an artificial landscape. Everything which was below zero was a lake or something, or the sea, and everything above was a mountain. And then I also started doing like first. It was not really ray tracing. It was like just simulating a light
Mhm. In shadow.
light
Mhm.
source, yes, and then doing some shading to have like shadows
And
and
it
stuff.
worked.
Yeah, it more or less worked. I still somewhere here have a picture which I took from my first PC from the screen, because there were no
Mhm.
color printers at that time. So I started doing photographs of my screen. Like,
Mhm.
I don't know, like you probably remember you had this VESA modes, like
Mhm.
640 to
P-
320 with 256
480, no?
colors. Yeah,
640 to 480.
yeah, exactly.
Mhm.
With 256 colors, which was
Exactly.
a great improvement compared to CPC and
Mhm.
to Schneider. Yeah, that time that was really fun. So
Okay.
these were my first programming attempts. And then when I started at university, this was also the time when I first got in contact with Linux. Like
Mhm.
like my first we had, when I was the last year in school, we had this. There was some, how, I don't know how to call it, like the special days for people from school to see what's going on at university.
Open doors or something, right?
Yeah, open doors, something like that. And I remember I went there, and the people already studying, they were all very impressed by Linux, and they tried to promote it. And it was possible to copy Linux there at the university. Because they had internet, they could download it.
Mhm.
I mean, at that time there was no internet, right?
Exactly.
So I knew that, and I took like 10 floppy disks with me, and they copied me Linux on them, like on 10 floppy disks with 1.4
Mhm.
megabyte each, right?
Mhm.
Then at home I started to install my first Linux, and it was very on a 386, and it was very happy when it first booted. And then I had the console, like started with C programming, GCC, and then like the real challenge was to get X working, like the
Exactly.
X11
Yeah.
X Windows system. So if
Yeah.
you could do that, then you were a real pro at that time.
Almost
Because there was no.
identical trajectory here, but I was maybe 2 years later, and I needed Linux for C because we did C at the university. I needed
Mhm,
a compiler,
mhm.
and you couldn't afford Unix workstation. I mean, this was crazy expensive,
Yeah.
so I was forced to install Linux, and just because of the C compiler. And I did it, and I wanted to have the windowing system and try that. And as I already mentioned several times on the podcast, so I had to disassemble my PC to find out the chip number. And if the I wrote it down because now I would take a picture, but back then,
Yeah.
and then put everything back and then you have to configure the chip number in the X Windows system, and there was like a text file, I remember.
Yeah,
But if
exactly.
you did it incorrectly, it was, you could even damage a screen something because the refresh rate was too high or whatever. So it was not that easy, but it worked. And I think the command was start X, right? With start X, you
X,
could
yeah.
start X. You could boot, or there were init modes. I think init modes, right? So the last one was Windows. So you can actually say,
Yeah, 8.5 or
I
something.
remember now, shutdown -H now is now,
Yeah.
right? At the boot time, you could say, which run mode or init mode you would like to have, right?
Yeah,
Mhm.
yeah, it was nice, yes. And then it was always like you had to catch up. You bought a better graphics card, but
Mhm.
then your monitor didn't support the refresh rate, so you had to buy a new
Exactly.
monitor. Then you had a better monitor. And then you had this awful interlaced modes. Maybe you remember. So
Mhm.
which did like 60 hertz, but megahertz, but only every second line
Mhm.
in the screen. So it
Mhm.
flickered terribly. But still, I mean, you wanted to do 1024
Yeah.
resolution
By 768.
by 768, but that for a long time that only worked in interlaced mode. So you probably damaged my eyes back then because I was,
You think it is not good for the eyes?
yeah, because these interlaced modes, as I said, they had like more than 60 hertz refresh rate, but always only second line. So it always had this background flickering.
Is it bad for the eyes, you think?
I think so, yes. I mean, I think there is a reason why today we don't work with 60 hertz anymore. Everybody has like at least 100 hertz.
Okay, this would be always interesting, to find out whether it is really bad for the eyes or just, it is unpleasant to work with. Would be interesting to know.
Yeah, I mean, I'm not a doctor, but
No,
I
but interesting, right? Because this is a common. If you have bad monitor, it's bad for the eyes. The question is really the case that the refresh rate is bad for the eyes, or it's just unpleasant to work with. Of course, now we have. I mean, there's different reasons. We have refresh rate that you can scroll and you see everything. It is nicer. It feels real, right? But what I had is I think it was called X Earth, right? The Earth in and this had to look nice. So because it was this was and X Eyes. I remember this was from this was where it tracked my mouse. So
yeah, exactly.
uh-huh.
And then
Okay,
Mosaic came up, the first
yeah,
browser, and it
hmm
had this turning globe. Maybe
yeah,
you remember. And
hmm
I always thought, oh my god, how can you do this so expensive? It's such a waste of CPU to have
yeah, yeah,
this turning world,
yeah, yeah.
this globe
hmm
running all the time. It must be an awful waste of CPUs.
You are right. This was my thinking. So I didn't like to play video on PCs because I thought, okay, this is a waste of PCs. I mean, you can pick video recorder and not work with PCs because they yeah. Uh, and now PCs became multimedia machines basically.
And maybe you remember at that time you had then X11, which was very basic. I also like doing. I always kind of like doing some graphics programming because I mean it was something visual. You could see.
Yeah.
But X11 programming was quite hard. So there was Motif, which was
hmm
much more pleasant, but you had to buy it. There was no open Motif at that time.
hmm
So I remember I think it was one of the first and few programs I really bought because as I said, I started using Linux and like this open source software from the very beginning. So I think for 200 marks or so, German marks, I bought Motif then, which was also on several floppy disks. And then
Could you buy it for Linux?
yeah. You could
Because
buy it for
I had
Linux.
at school HPUX and I really like the look and feel and I think it was CDE, Common Desktop
It
Environment,
was
right?
CDE,
Yeah, and
but
it was
that
not
was
available on
also
Linux, but there
yeah.
was a fake one. A KDE was not there, and it looked a little bit different because the CDE was at the bottom. There was like like you can switch between the screens, and this was not available on
Yeah,
Linux.
virtual screens, yes.
Yeah, and I didn't knew that. I will also buy this, but I wanted to have the same on Linux, but it was not. I couldn't find that, so I tried to replicate this and later it was possible, but at the beginning it was not. So interesting that Motif was available on Linux.
Yeah,
So
I'm not completely sure, but I think CDE was based on Motif, on the Motif toolkit. But I mean, would have to look it up. But
mhm.
I think it was X11. Then on top of that, there was Motive Toolkit, and then
Mhm.
like this Windows systems like CDE or others. And there was another one from Sun, OpenWin,
Yeah.
which was free. So that got free, and that was also very nice. So I also started programming with that. I did some function plotters and stuff like
In
that.
C, I guess, right?
In C, actually, yeah, even Objective C, which was the cool thing then, because there was no C++ at that time. So OpenWin was written in Objective C, if I remember right, and it had maybe you remember it had this round window. So everything else before was had edges. So OpenWin had round buttons and
Oh,
round window edges.
never
And
saw this. I think what I had the HPUX was rectangular, but it looked
yeah,
nice. It was not 3D, but it was at least had some structure. It was not flat. I don't know how to call it. So it popped out the window a bit. And okay, but I never programmed. I have to say what I did is I just used the stuff and I programmed C and C++. Actually, C++, C just a little bit, and then I learned C++ is the real thing. So I started with C++. But I did some algorithms, file system access just for fun. But I never opened a window on the Linux because I thought this is way too hard and impossible for me, to get. So I just focus on the core C++ templates. I was fascinated by operator overloading. So this like the most C in and C out, and I overloaded everything what's possible. So this was headers. This was my fascination back then. Okay, what did you do in the university? So you learned programming, graphic programming on the IRIX.
Yeah, I did some graphics programming on IRIX. I also learned C++ in, I think, the second year already. Like my starter class started with Pascal, which was okay because I knew it, so it was easy for me. But then, yeah, C. I mean, you had to use C for graphics programming, and there were a first course on C++, so I took it. I was also fascinated by template programming, and I did that for quite some time. I think I even wrote some papers on template meta programming when I was at university.
Wow,
So,
because templates were Turing complete. This was like language in the language, right? So templates you could,
yeah, exactly. Like,
and templates is I mean, maybe the Java generic is maybe 1% of the templates, right? So this is like, this is similar.
Yeah, because in C++ you could do then template specialization, and then with template specialization you could basically do this what was called template meta programming. So you could basically, as you said, it was Turing complete, so you could basically compute your program at compile time. So you could really drive the compiler to the edge. And for a very long time, compilers didn't really support the full standard. So it was always, I remember I compiled new versions of GCC almost every week because I hoped, they have this new feature and this new feature.
Exactly.
And the standard C++ library wasn't implemented completely. There were different versions of the standard C++ library. There were even companies selling Rockwave. I think they had like a more complete C++.
Rockwave is the company who later sold Java collection libraries.
Yeah, exactly. They started with standard C++ library.
Excellent.
So yeah, that were interesting times. There were like exotic computers like the EDG, Edison compiler from the Edison Design Group. They did I think the first decent
cool name, Edison Design Group.
Yeah, I think it still exists. I think they still do compiler stuff, and yeah, I think they were the first who implemented the full C++ standard at that time. So that was really cool.
What I remember, I wanted to understand templates more, but as you said, they were not available on Linux. I mean, the professor asked me to find it out, and there was CPP, I think, and G++, right? They were like the Linux compiler, and you had to do a lot of stuff. And it started to work, but not everything. And I was really frustrated because I didn't know what to do to get the full support. I couldn't understand that it's not supported now. I thought this is already there, but I'm not able to activate that. So this is my template story. So I used basically what I use in templates is more or less like generics in Java. This was my use of templates.
Yeah, yeah. There were. I now I remember there were already like a lot of compilers at that time. There was Whatcom C++. It only worked on Windows, I think. That's why I always had a double boot. I mostly worked with Linux, but I also had double boot to Windows. And
I always
then
destroyed
always
once a month. I destroyed the master boot record because and then nothing worked. But yeah.
And then actually my first internship at university was actually at HP, who were in Böblingen, which is not far from Tübingen. They had a big office there, big plant, a big office, and there I also worked with CDE, and there I did like my first program in Tickle.
Tickle
there
TC.
was this Tickle TK, which had this UI and Python. So that's where I started to use Python. Again, it was like, I don't know, 93 or so.
Wow. So
at that time, it was like, as I say, Tickle TK and Python. And from Python, it had no graphics at that time, but it could use the TK library from Tickle. So it was really nice. And now Python has this hype because of AI, right? But for a long time, like then in the 2000s, nobody really used Python anymore. It was basically dead, I would say, for a decade or so. And it's interesting to see how then it came back. But other things like Tickle, I mean, it was also a cool language by then, but probably nobody knows it now.
Yeah, I was in the early Java. There was an enterprise system. It was like PLM system. It was written in Tickle TK, and it was absolutely unmaintainable. So what they did, I don't know, but no one knew what's going on there. And then the outcome was that Python and Tickle TK was forbidden in the company. So it's okay. There's no other project is allowed to use that, and we had to migrate this to Java. This was, when was it? 2006 maybe. And you're right. So if I started with Java from the very beginning, and I always get the question, why you're not using Python? And I always had to do with Python programmers. So why not C++ was clear back then. So the arguments were C++ compiler is slow and there is memory management issues. So, but Python, always get asked, no, why you? And I wanted to learn Python, but I didn't like it. So I always, I took a look at Python. So okay, I don't care. And this was from the beginning. And then Jython came in, and people ask me, no, why you're not using Jython? I'm like, yeah, why I should use Jython? We have Java, and I bought even Python book. I only have to read them, but I don't know. Java gets better and better, and I'm very productive with Java. So still, I don't get Python now. But I understand. I mean, the Python is very good with matrix multiplication, whatever. But do you know the DJL library? Deep DJL from AWS, actually, from Amazon or AWS. And you have to look at this because the cool story is, in the library, you can very easily manipulate arrays and metrics.
Okay.
And it is the same as in Python. And this is fun because you can say, metrics fill with numbers and you get it. Then multiply metrics with other metrics and you see this on the screen. And this is and it is actually used by AWS or Amazon internally to speed up things. So this is open source. If you search for DJL, you will like it. If you like a little bit math, so you will like it. It is unknown, but it surprises me because it interacts behind the scenes with the I think PyTorch or the newer one. And it is meant to speed up the entire thing. And this is well documented and actually great machine learning library, but not that known, which surprises me. It's open source. Cool. So okay, you did Tickle at HP with Python, and what do you build there?
Like in Böblingen, they did this. They didn't really do software. They did this cool measurement stuff. So I remember I was in a department which did there was this VESA bus at that time. It was before PCI came up, and the VESA bus they basically did tools like hardware tools for measuring VESA cards. It was very, very, very specific. They were very expensive, and they basically they run on a mainframe basically, which had a HPUX operating system, and then they had some of these extension cards where VESA card vendors could test that their cards are fulfilling the VESA standard. And I
It's
basically
interesting
did
because this is like a test bed for graphic cards.
yeah, but VESA was not just graphic cards. It was like PCI today. It was
For
like
then VESA cards.
Yeah, and I did basically I wrote a how do you call it a database for managing these systems, because they didn't sold a lot of them, like hundreds of them, but they all had like a number and customer and some issues, and so they didn't really had a good database to handle all the data for this single systems. And I did this so that they were very, very impressed that you can do that with graphics, so you don't enter it in a console. But and with TickleTK and Python, it was easy to create like masks where you could put in input all this stuff. So yeah, it was kind of it was just for this department the system to keep track of their inventory and the systems they sold,
cool.
where they were. And so yeah.
What happened then? So what was the next interesting?
What happened then? Yeah, then I think that was also then the time when I started using Java. It was also like Java 0.8 or 0.9.
Wow. Why? Why so early?
I don't know. Actually, I think I saw a book in our library, which was this Java in a nutshell. The very
from David Flanagan.
Yeah, the brown one. Yes. I still have it, and it sounded interesting, and this was especially interesting that, especially for me at that time, that Java basically had built-in support for multi-platform graphics and multi-platform networking. Because at that time, I mean, the internet came up. I obviously had a modem at home, and you could do like things like Telnet or FTP and stuff like that. But it was very hard to write platform independent networking code. Maybe you remember on Windows, you had to install this network extension. Windows 3.1 was the one which was
even something with Trumpet or something, right? So Trumpet socket
Trumpet sockets, yeah, exactly. And then Windows 3.11 works. How was it called? Windows for Workspaces is something that came out, and that had already this network stack built in, but still, like the C API on Windows and on Linux was completely different. It was a mess to program against that. So Java had this. I mean, that impressed me from the beginning. This write once, run anywhere, and at that time, it really worked, like on my Linux and on my Windows. So on Linux, there was actually no official JDK on Linux at that time. Maybe you remember there was this. I think they called it Blackdown.
You know who programmed the Blackdown?
No.
Johann Voss.
Really?
You know Johann Voss? Yeah. This is the guy, sure. JavaFX guy. He was one of the guys. Yeah.
Okay. Wow. Cool.
Yeah, he was also on the podcast, so we had chat with him. So I also didn't know that. And I was a Java 1, and I saw the Blackdown Linux, because not by Sun Microsystem. It was created by Johann, and then later adopted by Sun.
Okay. Cool.
Yeah.
Sun had only Windows and Solaris versions at that time, and then IBM quite early created the version for AIX. So at university we had all this zoo of different Unix systems, which I also found very interesting. And this was a great school for me later when I worked at SAP and basically ported Hotspot to IRIX and HPUX and AIX and all these operating systems. So my first contact with all these Unixes was at university, and it was cool. You had like all these different rooms with all kind of workstations. We had I remember we called it Solarium. That was the room where we had the Solaris
cool.
Solaris workstations, yeah. And but it was cool that you could basically install Java on Linux as well. And then I remember I did a presentation at a professor and this working group about Java. and I highlighted basically this networking, and the other thing that was also impressive was that it supported multi-threading. It was also like something new at that time. Like at home, you had only one CPU, but
and string. There is string. The string was impressive. That we have a string, because what I remember in C and C++ even in the standard, you had to have character array which was terminated by 0, I guess, right?
Yeah. I mean, C++ also had a string class, but it was very complicated. You had to.
Was it built in? No.
Yeah, it was in the standard library. Yeah, STD.
Yeah, STL. But STL you had to. But
no, not in the STL. In the standard library, you had this STD string, and it was basically a template type with a character or white character. So it was very complicated to handle it, and Java had basically this Unicode string. So they had strings and they supported Unicode, which was also a very big thing at that time, because Unicode, like before, you had all these different code pages, which was really a mess. Especially like in German, it's not that hard. You have like just a few umlauts, but other languages were almost impossible to write at that time. And if you wrote it on one computer, it for sure didn't run on any other computer, because it didn't have that specific code page. And then I remember I did one of my first jobs for Davis, which was like Daimler-Benz Interservices. It was a IT company of Daimler at that time. It later was acquired by T-Systems. It's now part of T-Systems since a long time. But I started at Davis, and I did the project again where I wrote a Java applet to access their data. They had a product called NormMaster, which was a database of all the DIN and ANSI norms, because Daimler, as a big company, they had to follow all the standards. So I wrote and they only had like text interface to this, and it was very hard to search for this standard. So I wrote an applet which was running in the browser, and that was it was easy to run that. And they also like they used the Solaris workstations, but they also had Windows clients. So this was like very easy to write something which ran on both. Like the
was it your first serious Java application?
I think yes, it was. At least I got money for it.
Very good. So you work as a consultant? You are a freelancer, or?
Yes, as a freelancer. Yes, during I was still studying, so I first started doing like the exercises with the younger students, and like
yoga, right? Yoga.
Yeah. It was called HiMEM in German. It's Hilfswissenschaftler, like
these are
research assistant or something. Yeah,
consulting scientist.
Yeah, like I think my very first job at university was for the Max Planck Institute for genetics. This again was interesting for me because as I said, you're also interested in biology. Yes. And I remember first day I came into the institute, there were these flies flying around, but it was not just flies, because they all had like a number on their back, a very small number. So they basically tracked them and did some experiments with them.
I thought you saw the predator plants again. So
no, but I didn't do there something with biology. It was again just a program written in Pascal, but not for PC, but for some strange DEC workstations. So that was my very first job, and then I did this like this heavy job, like teaching younger students and stuff like that, and then my internship at HP, and then I started working like as a freelancer for actually until the end of my study at Davis, and then later T-Systems.
I used to keep doing Java then.
Yeah, the first project was in Java, but then later on I moved back to C++, and I did some more serious, I would say, like client server application, basically writing an well, it wasn't really a full-blown application server, but it was like a server who I did it together with my best friend. My best friend was writing the UI on Windows, and I wrote the backend server. Again, it was for this NorMaster and ImageMaster product, which basically served all the standards. And it was really interesting because it was for Airbus, and Airbus were doing these planes, right? So they had a lot of technical drawings, and these technical drawings were actually on punch cards. They pimped the punch cards in that half of the punch card was just a picture, like a slide.
So you could see the picture on the punch card.
Yeah, the half of the punch card had an integrated slide of the technical drawing. It was small, but you could scan it. You could look at
wait a second. So you could see the drawing looking at the punch card, or was it encoded? Was the information on the punch card, or was it the drawing?
No, you could really see it visually. As I say, it was a real slide. Like, you remember slides?
Yeah, slides. Yeah.
Yeah, and it was like a microfiche. Like it was a picture of a very large drawing of I don't know, some
this
element.
Is crazy. Okay.
Of like a technical drawing of a wheel of a plane, or sometimes just a screw or something from a plane. But this was like a picture of the technical drawing, and then the punch card itself only had the bibliographical data, like a number, what it is, and some index and some stuff. And this was how Airbus managed their technical drawings for like decades. And then they wanted to digitize that, and that was basically the project. We had a scanner for these punch cards, so we basically scanned the index data from the punch card, and the scanner also scanned the slide, and then it was transferred. It was basically digitized into a database, and I basically wrote the server who talked to the scanner.
But the picture was huge, right?
The picture was huge, yes, sure. It was saved in, I think, as a TIFF or something.
How big was it? 1 gig or something? TIFF is a...
No, not 1 gig. At that time, 1 gig was elusive, but it was certainly several megabytes probably at that time. I mean,
okay, this was a black and white, right?
Yeah, it was just black and white.
Okay,
because it was technical drawing. Yes.
Okay.
It depended on with how many DPIs. I think we scanned with 300 DPI or something like this.
Because there were this is a slide, this DIA, DIAs, right? So the slide, exactly. There were scanners for it, and I remember I also did it for fun. But the TIFFs were huge. This is what I remember, in color. But you were black and white, so it was smaller.
We were black and white. Yeah, we just
cool project. So what was your next Java project actually?
The next Java project, let me think. Yeah, my next Java project was at university when I did my PhD.
What was the title of your PhD?
Sorry?
Title of your PhD.
My PhD. It's even hard to remember.
Or what was the topic roughly? You know?
I wrote a software to analyze and create parallel. That was also the title, I think. Creating and analyzing parallel text corpora or something like that. Mm-hmm. So in Tübingen, it's a very old university. They have a lot of humanities, and I was always impressed. I mean, I'm not religious myself, but like for the theologists, they had these huge books where they had like the Bible text in like 4 or 5 languages. Like they had the Hebrew and then Greek and Latin and German translation, and then different versions of that. And like the footnotes are almost half of the whole page. So the book itself was huge. And then it had like all these columns with the different languages. And I think it's called Concordance. So basically you try to find the same places in the different translations. and I basically built a system, a digital system for that, so that you could basically align different versions or translations of the same text, or it could be like a facsimile, like a picture with the OCR system, and then translate it to real text.
OCR is object character. No, what is
character recognition? Yes,
object?
optical character recognition.
Optical,
yes.
Exactly. Optical character recognition, exactly.
So
you wrote it in Java?
Yeah, I wrote it in Java. I think I started with Java 1.3 then. So it was already quite new. And then
with
at
hotspot.
the end, I
1.3 is the first one with hotspot, right?
Yeah, the first one with hotspot, yes. And at that time, there was also like quite some development in Swing. So Swing got better and better. Like before, you only had AWT.
But 1.2 introduced really Swing, and 1.3 is Swing, exactly, which got faster and better.
Yeah, it was first called JFC, Java Foundation Classes. It was, I think in 1.2 or so, it was still an external library which you could download, and then it became part of the
and Java. This is the first huge refactoring, because it was ComSan Swing, and later it was Java X Swing. So we had to refactor the projects.
When it became part of the standard, right? And then it had these cool things like now you didn't have Unicode only in the strings, but you could really draw all kind of scripts, like left to right, right to left, Cyrillic, Chinese, I don't know, Tamil, Ethiopian, all this kind of stuff. You could really draw it, and they had support for that in Swing. And at that time, the biggest problem was to get a good font for it, because there were actually almost no vector fonts available which contained all the scripts. And there were a lot of problems also, because some of the rendering didn't really work correctly. And
it was not well tested, I guess. So exotic.
Yeah, it was not well tested. And also the computers didn't have that much of memory. So it's like doing this rendering each font, each glyph basically, and then doing kerning and hinting and anti-aliasing. That was quite expensive. But I like the topic. I think I wrote some journal articles for Java journals about, I think one was called International Swinging. So I basically
cool title.
Wrote a library which made it possible to change the language of the UI itself on the fly. Before, like otherwise you could do it in Java by defining resources and
exactly
and the local at startup.
Java was also big, the internationalization, and there was two internationalization, I18N, right? And the other one was internationalization and localization. Localization. Exactly. Internationalization is translating basically, and localization is units or dot and comma and stuff like that, right? So in numbers.
Yeah. So I played a little bit with that, and at that time I worked a lot with Java, especially with Swing and with that.
So what did it exactly? So you display the books in a Swing panel?
Yeah, you could basically load different versions of a book, and then you could basically try to automatically find correlating parts.
Wow.
Or doing different indices like quick index or stuff like that on each of the page, and everything was linked together. Like I basically, also XML was very popular at that time, so I defined some XML style sheets to
also very memory efficient, right? So
so you could basically encode these texts in a way where it automatic where it linked the corresponding.
So you use XLT, I guess, right?
I used XLT.
Wow. Okay, then CSS, Xenon.
yeah, exactly. The first versions of these libraries. So you could basically read a book, for example, in German, and then click on a sentence, and then you saw the original, which was maybe written in Russian or in English.
So like the first version of Kindle you created, right?
yeah, I think it had a lot more features than Kindle today. Yes,
Mhm.
and yeah, I did that for a few years. I think I also presented at Didacta, which is like
Mhm.
a conference in Karlsruhe about
Mhm.
teaching, and so I had a booth there. But for some reason, I didn't get any funding then for continuing the work on that. So after my PhD, I had to start to do real work, not at the university. Like I really liked being at university,
Mhm.
but yeah, I looked for a job then, and then I found a job at Sun Microsystems. So that was my first real job then.
When was it? Which year?
It was let me think. I started it was probably like 2002 or three, around
Uh-huh.
the time. And
Because I've worked as a freelancer. I delivered the Sun courses. I
okay,
think between 2000 and 2006, 7 or whatever.
okay,
So until the end. And this is why I'm asking because
okay.
uh-huh.
Yeah, I moved to Waldorf because they had an office here in Waldorf because they were aligned with SAP, doing the SAP alliance together. But it was actually the department was called MDE, Market Development Engineering. They were basically trying to support big ISVs using any kind of Sun product. So it was not really related to Java. What I actually did was the project I did was porting MaxDB to
Huh.
Solaris.
I use MaxDB a lot. It was a SAP database, but
Exactly.
open sourced, and you could use that and gain traction because they had a nice UI as well.
Yeah.
And
Yeah.
exactly. What and what was the origin name? It was not SAP. What was the name? MaxDB was the open source one, right? But this was one behind was a commercial one.
Uh,
It was from
yeah.
SAP. Mhm.
Adabas, I think.
Yeah, I
This
guess
was the
so.
commercial one. Was I mean I think SAP acquired Adabas and then they made the open source version, which was called MaxDB.
I
The
used it a
problem
lot,
was
and also interesting. I delivered the Sun courses because you mentioned this right now, and I remember SAP Sun. No, there was Sun SAP Competence Center,
yeah,
and the
exactly.
people
That's there where
attended
I worked.
my
Yes.
course, and they were really good because I
Okay.
asked them what they are doing, and they couldn't understand why they are working for SAP or for Sun. I don't know, but there was some relation between them, and they were in charge of running performant Java application at SAP or something like this, and they were really good. We had good conversation with them. There's like no special forces. Yeah.
Yes, so there was this problem because maybe you remember Solaris at some time it Solaris 2.6 or 7 it ran on x86
Mhm.
and then Sun dropped x86 support for some years and only supported Spark. And then with Solaris 10 they did a big relaunch to support 64-bit x86.
Mhm.
But at that time already, all the companies were reluctant to port their programs to Solaris x86 because they said, "Oh, you already dropped support one time. Why should we trust you this time?" And SAP is especially good in leveraging the partners. So they said, "Yeah, we will support MaxDB on Solaris x86, but you have to do the port." And this was actually then my job. So I
Ah,
basically ported then MaxDB from Solaris Spark to Solaris x86. It was interesting, but I really wanted to work more with Java, but it wasn't possible at that time to work remotely for Sun in the engineering teams for Java because they were all in the Bay Area. And then like after 1 year at Sun, SAP started a new team to work on their. They decided to their own JVM, SAP JVM, and they created a team for that. And then that was basically the time when I moved to SAP and when I started to really work on Hotspot itself on the JVM
mhm.
because before I basically only used it. And yeah, I think then at SAP we started to,
Then
as I
I will
mentioned before,
re-invite you back and talk exclusively about
yeah,
your low-level Java because we learn more about Java stuff. But what I'm thinking about, I was relatively active one period of time with MaxDB. I mean, I used that, and I also talk at conferences about that. I remember also, and there was a big interest, and I also get requests, but I forgot why, because it was widely unknown that MaxDB is open source. So there was like,
Yeah.
because and it was very interesting technology. It was also very fast database. And back then, I think I still had Windows, pretty sure. And the user interface of MaxDB was good. They have like an admin interface which you could launch, and everyone was impressed that this thing is free. So and we used that actually in real project. I completely forgot about that, about MaxDB. But
Yeah.
then it somehow disappeared. So what happened with MaxDB? So it was like supported, not supported. What happened with it? You know it?
I have no idea. I agree. It was really superior to MySQL at that time,
Yeah.
and it ran on Linux, on Windows, on Solaris. It was free. It was 64-bit, so it was really cool. It was not easy to set it up and to compile it and to manage it, because it was like a real database. But
Mhm.
I don't know. I mean, SAP tried for a long time and still tries to get rid of Oracle, because all the SAP or all the SAP applications, they are written in ABAP, which is their own programming language.
Mhm.
But they all require a database, because like ABAP is a strange language. It's actually it's not stored in the file system. The language itself, the code itself, is stored in the database, and then it needs the database for everything. It uses the database for everything.
Yeah.
It's a kind of
Then information for you, because as I got a job as a freelance trainer for some microsystem to teach ABAP developers Java. So I spent some time at St. Leon Road, and there were hundreds of developers. But the cool story is I was always challenged, because they said, okay, we have interactive development, and they showed me this, right? So it ran more or less interactively in the database, and there was like the database in ABAP was once. And they asked
yeah.
me, now, what do you do in Java? So I try, to explain them. And but the interesting part is I wanted actually to learn from them what's cool about ABAP, and they were really motivated to learn what's cool about Java. So the course was 1 week, but I would say on Wednesday we aligned and we learned from each other. And actually, what happened on Wednesday, we spent a lot of time after the workshop talking about stuff. And I even learned once a guy who created actually the R4 or R3, the virtual machine, which runs the thing in the garage with the origin founder of SAP. This was an interesting guy. So we had an intense discussion about that. And this was actually a cool time. And what's interesting also, the St. Leo Road, the training center, was in the near of a golf park or golf
Yeah,
course or something.
yeah,
Yeah.
that's
So
true.
what I walked there with the attendees, and we talk about ABAP and Java, and they were playing golf. This is what I remember back then.
Yeah.
So this was, yeah. Yeah.
Yeah, so it seems like our ways crossed several times without noticing. So
But we never met, right?
yeah, probably not. Maybe we met and didn't know each other.
Yeah.
Who knows?
Yeah. So we met last week at JFocus, which was a great conference for me. So I was really surprised how well it was run and how popular it was actually.
Yeah, I liked it
So
too.
thank you. Where people can find you on the internet, and are you
Yeah,
visible somewhere?
I'm still on Twitter.
Uh-huh.
I'm on LinkedIn.
What's your handle?
Volker_Simonis or Volker.Simonis. I think it's not really not hard to find me, because my name is probably unique in the
Uh-huh.
world. Like Volker Simonis, just Google it. I have a pretty old homepage, but you will find my contact data.
But I think it's just with right Unicode characters, so this should be work perfectly, right? Your
Yeah,
homepage.
Volker is written like it's pronounced Volker in German, but it's written with V like Victor. Like Americans usually
Mhm.
pronounce it Volker,
Mhm.
but Simon is like in German Simonis. It's pretty easy, Simonis. So yeah.
Yeah, super cool. So see and hear you next time.
Yeah, it was nice to talk to you. Have a nice day. Bye bye.
Thank you.